Introduction to Three-Dimensional Learning, Funds of Knowledge, and Place-Based Science.
How can we make symbols for grass, for example?
These videos show Melina Lozano's first attempt to teach the NGSS with her students. She is a new teacher, but loves teaching science.
I'm teaching at an elementary school in Madison, Wisconsin, and we're in a second and third grade bilingual classroom.
How did they get to this place of modeling and sense-making? How did Melina's shifts take place? Melina already has a strong linkage with her students through connections with families and with the students' language and culture. She is ready to start changing thinking about approaching science teaching to support three-dimensional learning.
Okay, let's do it.
Three-dimensional learning means that students use disciplinary core ideas, scientific practices, and cross-cutting concepts to make sense of phenomena they experience in their environment.
So the 3-week unit examines in detail how water interacts with the land and then how the land in turn interacts with the water. We start with sort of just beginning understanding and beginning to make explanations with evidence, and then they use a model to sort of try to figure out if there's a way that they can show what they understand. And in NGSS, that model becomes increasingly more sophisticated over time. So their first interactions are more like they're just kind of discovering and thinking through things. And then they gradually start getting more and more information that they can use to refine their model and revise their model. And they're also developing more complex language, more scientific language. In the end, they're going to be figuring out a way to stop the water from changing the land. So they're going to have an engineering solution where they're presented with some kind of problem, like a puddle underneath the swing, and they have to figure out how to use the knowledge that they've collected to solve a problem. So the end lesson can be sort of like an assessment where you're really seeing what do the kids learn from this unit.
In these videos, you will see our students participating in collaborative conversations and engaging in three-dimensional learning to make sense of phenomena they experience in their lives.
Are you three a partner? The three of you?
What do students already need to know?
Mud. When it got wet, when it was raining, and then when people stepped on it, they left their footprints on their shoes. Your shoes make prints in the mud.
Students will need to be able to describe their background knowledge and experiences and use language to describe ideas and questions about rain events.
We found a puddle. It was over there, and it was wet.
The biggest difference with NGSS in general is that it highlights the kind of place-based science as something that makes sense, because it means we can't, necessarily use a textbook as our #1 source. And so we are going to go outside and we're going to get ideas from parents, and we're going to get ideas from the kids. And so because we're putting the kids in the center, a lot of kids who aren't used to their voices being as powerful in the real world suddenly become powerful in this classroom. This lesson had a component where the kids went home and asked their parents about where they found evidence of rain, and that was done in their own language, in their home language with their parents. And the point of that is to start that conversation at home also, and to make the ideas that they had at home really important and really essential part of our meaning making in the classroom.
Wet mud is evidence of rain?
Wet mud is evidence. I don't know what that is. How do you write wet mud? Yes, me too. How do you puddle? And then rock.
As the lessons progress, you will see that the students build ideas simultaneously as they acquire the science or academic language, both the vocabulary needed to discuss the phenomenon and the sense-making talk of building meaning collaboratively. They engage in the scientific practices of gathering and using evidence to write claims, arguing from evidence, conducting an investigation, and modeling how rain changes some surfaces and not others. These practices, one dimension of the NGSS, combine with the cross-cutting concepts of patterns and cause and effect, core science ideas of erosion, interactions between water and land, and rapid and slow changes that result from the interactions.
So what's going to happen when we pour the water on it?
What do you think? What do you think?
It's gonna turn over.
Curriculum author Emily Miller team teaches with our classroom teacher Melina to implement the shifts required so as to align with the NGSS.
We agree, right? I'm going to draw it. This is evidence. It's wet here and it's raining.
The students will collect evidence that the rain event occurred and work together to present claims with the evidence that we collect. We will move from informal language of speaking to formal language of writing in our claim.
I think it rained because we saw footprints with mud.
Is that evidence? If we give a thumbs up or a thumbs down, is that evidence that it snowed? Why are you saying no?
We ask the class a series of questions in order to clarify comprehension, gather additional information, or deepen their understanding about the evidence that it rained the night before. We start with an image of a snow scene in a forest. We are informatively assessing the students' capacities to use evidence and to think about rain and snow to describe the evidence.
Yeah, dinos. En español o como quieras.
I don't know how to explain it.
Okay, how about in any language?
I don't know which.
Watch how the students on the first day struggle to make themselves understood, to listen and make sense of each other, and to think about what their friends say.
Did you find some evidence of rain?
Our goal is not to start with seeing the young students as lacking skills and knowledge and scientific lenses, but so that we can set up activities that help us gather information the student knows and build on it. In addition, we are looking to see what skills the students bring to the discussion in terms of language and also in terms of the academic discourse needed to exchange ideas.
It's like when something happens, like it rains or snows, the next day you'll see that the snow's in the ground, and if it rains and the next day is sunny, when you wake up, when you walk on the grass is wet, and you see mud puddles and puddles of water.
The students will go outside and search for evidence that it rained. The fact that it rained in the neighborhood, a usual event, will spark the rest of the unit. Students are asked to go home and talk about the evidence that it rained at home so they can bridge the home and community with the science they do at school. We will examine the idea of three-dimensional learning over the course of this set of videos. What does it actually mean to teach in 3 dimensions? What does it look like? And what is easy and difficult about teaching this way? The NGSS mean that learning is student-centered and the teacher acts as a guide, building on what students understand. This is a shift in the role of teacher, and it is challenging for Melina. She doesn't always feel effective. Reflect on your own struggles with this shift. How are you coaching students to use what they know and think in more complex ways about the same idea?